Hi, Math 96. If you were absent on Tuesday, we did classwork, and I just wanted to make a video in case you were absent that day. We went over again this chart that's on page 4 of your notebook, and we just talked about how we focus on the square root, cube root, fourth root, fifth root, and sixth root, and this is on page 4 of your notebook. So if you need to know what the cubed root of 64 is, it's 4. You should know the square root of 64 is 8. You have to be careful with 64 because also the sixth root of 64 is on this chart. It's worth 2. The reason why, for example, why is the cubed root of 64 4? It's because if you multiply 4 times 4 times 4, you need 3 of the same matching number because your index here is a 3. Out comes 4. Same as if a square root, the index number here is a 2. Square root of 64 is 8 because you have 2 matching numbers, 8, for 64. Cubed root of 64 is 4 times 4 times 4. You need 3 matching numbers. And over here, the sixth root of 64, if you break this down into 2 times 2 times 2, 6 times, because the index again right here is 6, 3, 4, 5, 6, you have 6 2's that multiply out to 64. That's why the sixth root of 64 is 2. Okay? So you're going to be using that chart during this presentation. I just took those square root, cube root, fourth and fifth and sixth root and just made them a little bigger because I will be referring to this in the lecture. So this is classwork. Please listen for just a moment. You do not have to write these problems down. Please just listen. So the square root, cube root, and what we call nth root. So anytime you get above the number 3, like the fifth root, eighth root, fourth root, we just call those nth roots. Now, one important thing you need to know is for all square roots that there is a hidden 2 right here. You should have learned that in Algebra 2. Because the word square, it stands for a 2. Okay, so this first one is square root of 49 is just 7. When you have a negative on the outside, that's okay. You just bring it down. Square root of 16 is 4. So this answer would be negative 4. This answer would be 7. When you have a fraction, square root of 36 you just do on the top. That's 6. And the square root of 49 on the bottom is just 7. So don't be afraid of fractions. And again, it's okay to have a negative on the outside. Square root of 16 is just 4, and square root of 81 is just 9. Now, you're not allowed to have a negative in the inside of a radical if your index number is even, like 2 is even, or if you had a fourth root or a sixth root. So negatives cannot be in the inside for even roots. Now I'm going to show you why. If you did the square root of 25, you should know that's 5. You cannot do the square root of negative 25 because for this one you have a pair of 5's, out comes 5. But you do not have a pair of numbers for negative 25. These don't match. This is negative. This is positive. So you cannot do a square root of a negative when this is an even number. So a square root, fourth root, sixth root, you cannot have a negative in the inside. But you can do them when you have odd roots. So we're going to do that when we come to this one. Okay, cubed root of 27. You could sit there and break this down, 9 times 3, and then break down the 9 into 3. And you would see that you need 3 of the same number. Cubed root of 27 is 3. You can also just refer to this chart. It's right here. Let me move this down a little bit. Cubed root, right? It's right here. Cubed root of 27 is 3. Now, why can I do a negative when this is odd? I'll show you why. So 64, if we go over to our cube root chart, cubed root of 64 is 4. So you ask yourself, is negative 4 times negative 4 times negative 4 worth negative 64? It is. You have 3, because remember, you need 3 of the same number. So the cubed root of negative 64 is negative 4. And then when you have x, and we're going to study this today, you can break up x cubed into x times x times x. So you have 3 of the same things. So out comes x. All right. And so I wanted to make sure I have students who always forget about 1. We're just going to do the top, right? And don't forget, 6th root of 1 is 1. 5th root of 1 is 1. 4th root of 1 is 1. Cubed root of 1 is 1. Square root of 1 is 1, right? Because 1 times 1 times 1 is just 1. So I often have kids who forget, so I always do that. And so this is an odd root, so it can be negative. So the 5th root of negative 1 is negative 1. 5th root of 32 is 2. How did I know that? I went over to my chart. Right here is the 5th root of 32. And it tells you right there that the 5th root of 32 is 2. Okay? And then now this one says this is how many of the same thing, and you can break up y to the 8th as y times y times y times y 8 times, right? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 of the same thing, so out comes the y. Okay? Just like up here, I needed 3 of the same number, and out came the single 3. Over here, out comes a single y. This is what we're going to practice. So if you can hit pause on this video and just write these problems down and then go back and turn the video on. We're going to talk about who's out and who's in. So hit pause and write those down and then start the video back up. Okay, you should have written these all down, and now we're going to do them together. This is a square root. I need you from now on to always fill in that hidden 2. Okay? So the index, the 2 is called the index. It says you need pairs of 2. You need pairs of the same item to get out. So when I have x to the 6, I'm going to write 6x's in pairs. Just like for square root of 25, we wrote 5 times 5, out comes 5. Here, every time you have a pair, something gets out. So out is x, out is another x. Just like 5 got out is another x. So how many x's got out? 1, 2, 3. So the answer is x to the 3rd. So we're going to practice that about who's out and who's in. The next one's going to have an example of items that have to stay in. So for this work, this is how I want you to do your problems. I want you to draw an empty radical. You must include the index, which is 3, cubed root. And it requires 3 to get out, not 2 like this index, but 3 sets of 3 to get out. So you're going to get some things that are going to be out of the radical and some things that have to stay in the radical. So that's why I call this who's out and who's in. So one thing at a time. Cubed root of 125. If you don't know that, you go to the chart. Cubed root 125 is right there. It's 5. Out is 5. Because 5 times 5 times 5 is 125. Okay, x to the 8th. We're done with the 125. I'm going to draw them in sets of 3 because you need 3 to get out. So there's 3, 4, 5, 6, 7, 8. Sets of 3, out is X. Set of 3, out is X. These are out. There's not 3 here, so these are still in. So when I write my answer, the ones that got out are X squared, 2 of them. The ones that have to stay in are also 2 more, so X squared is in. If this is confusing, hang in there. The more we practice, the better it will get. I'm now going to draw y to the 6. I'm going to draw them in sets of 3 because it takes 3, because it's a cubed root, takes 3 to get out. So out is y, out is another y, so the ones that are out are y squared. There's nothing else to stay in. Let me just move this over a little bit. There we go. Make sure that this bar is tall enough that that 3 doesn't get hooked onto your y. Okay? All right, let's try some more. Make sure you have page 4 of your white notebook handy so that you can do these roots with me. So the first one, it takes 4 to get out. We need the 4th root of 16. So go to your chart, go to 4th root, 16. The answer is 2. 4th root of 16. I'm going to draw my, oops, sorry about that. My pen went a little funny. My 4th root. So 4th root of 16, out is 2. I'm done with 16. Now I'm going to do my 8, x to the 8th, and it's sets of 4. That's 8 of them. A set of 4, out is x, out is x. These are out, so I got x squared out. Then I'm going to draw the y's. I have 5 y's. 1, 2, 3, 4, 5. I'm drawing them in sets of 4 because it takes 4 to get out. So out is a y, and still in is a y because there was an extra one left. So out is y, in is y. Okay, let's try one more. Okay, I'm going to erase this. Okay, we're on to a 5th root. It takes 5 to get out. So what's the 5th root of 32? It's right here. 5th root of 32 is worth 2. So make sure you use this page 4 of your white notebook. So who's out and who's in? So far, 5th root of 32, out is 2. We're done with 32. X to the 8th. I'm drawing them in sets of 5. So 1, 2, 3, 4, 5, 6, 7, 8. It takes a set of 5 to get out. So I got an X out. There are still 3 X's in. I got an X out, and there's still 3 X's in. So X to the 3rd. Now I'm going to do the Y's. I'm just waiting for a minute for you to write that down. You can always hit pause on the video also if you need more time. Okay, now we're going to do the y to the 7th. I need to draw them in sets of 5. So 1, 2, 3, 4, 5, 6, 7. It takes 5 to get out. So y is out. These are still in because I only have 2 and I needed 5, right? So y squared is still in. So there's all your answers at the bottom. And that's the idea of who's out and who's in. You're drawing them and looking at the index number to figure out who's out and who's in. Okay? All right, I want you to go ahead now. This is what we did in class. I had everybody write down these 5 problems, and then I gave them 8 minutes to do them. So hit pause on the video, write these down. Don't forget on this one that it's a square root. That means you have to add in the hidden 2. Add in the hidden 2. I usually say hidden 1, right? So you have to put a little 2 there for square roots. Get in that habit, okay? All right, hit pause. See if you can finish within 8 minutes and then come back to the video and I'll do them for you. So hit pause, please. Okay, hopefully you hit paused. So we're going to get started. Square root of 64 is 8. Out is 8. So we'll leave the who's out and who's in. I need to definitely change it. Pen is too skinny. Let me just change it here. There we go. Okay. That's a little better. All right. We're done with 64. X to the 4th. I'm going to draw my x's in sets of 2. Out, out. So x squared is out because I got 2 of the x's out. And then I have y to the 6. Sets of 2. 2, 4, 6. Out, out, and out. That's a total of 3 y's out, and nothing is left inside, so I'm going to erase it. So sometimes there's not anything left inside. Okay, next one. And remember, you can always hit pause and go back on the video if you need to. Cubed root of 64, you can go right to your chart. Cubed root 64 is 4. So I'm going to put my who's out and who's in. So cubed root is 64, out is 4. I'm done with that number. X to the 7th, I have to write it, the drawing, in sets of 3. I need 7 total. There's 7 of them. So out is an X, out is an X. So out is X squared. Still in is 1X. And then I'm going to do Y to the 3rd. So I did x to the 7th, and then y to the 3rd is obviously just 3 y's. It takes 3 to get out, so out is a y. And that's your final answer. Okay, next one. 4th root of 81. And then I'm going to draw my who's out and who's in. 4th root 81 is worth 3. So out is 3. And I'm going to move on to x to the 8th. I need them in sets of 4 this time. So there's 8 of them. So out is x. Out is x. So 2 x's got out. X squared. I'm going to draw my y's off to the side here. So I have y to the 6. I need to draw them in sets of 4. 1, 2, 3, 4, 5, 6. Out is y. In is y squared, right? Because there's 2 of them. And that's your final answer. Now, if you needed this extra couple of problems to really understand this, hit pause and finish up 4 and 5 and come back to the video. So if you needed just a little more support, then go ahead and try 4 and 5 by hitting pause on the video, and then you can come back and check. Okay, 5th root of 243. 5th root 243 is right here. The answer is 3. So out is 3. I'm done with 243. X to the 10th. I have to write them in sets of 5. So there's 2 sets of 5. So x squared is out. X and x get out. When we have 2 of them, we just write x squared. y to the 6. I have to write it in sets of 5. 1, 2, 3, 4, 5, 6. So 1y is out and 1y is still in. Okay, next one I'm going to write 6th root. Take 6 to get out. 6 through to 64. If you look on your chart, I've already talked about that one. It's over here. It's worth 2. 2 is out. X to the 12th. Well, if I know I need 6 for each set, isn't that 2 sets? Because 12, right? Sets of 6 means I would have to do that twice. So out would be x squared, right? That one's out as x squared. And then you should intuitively know that y comes out for y to the 6, but I'll draw it for you. There's 6 of them, so out comes a y, and there's nothing left inside. So I'm going to erase the radical, and that'll be the final answer. Okay, that's what we did yesterday. Who's out and who's in? That's what we call it. Who's out and who's in. Thank you for making this up. You do not need to upload it to your digital workbook. This is just for your reference. So it was just practice for class. Have a great day.